Momentum is conserved in all collisions. In an elastic collision, the forces between the colliding objects are conservative. Both momentum and mechanical energy are constant in an elastic collision. Some of the initial kinetic energy is converted to potential energy during the collision, and that potential energy is restored to kinetic energy after the collision. An inelastic collision is one in which there are non-conservative forces between the colliding objects. So some of the initial kinetic energy is dissipated, turned into another kind of energy. In this case, momentum is constant in the collision, but mechanical energy is not. In a completely inelastic collision, the colliding objects stick together. Momentum is constant, but the maximum amount of kinetic energy possible is dissipated as other energy. If the initial momentum of a system is not zero, then not all of the kinetic energy can be dissipated, no matter what kind of collision. Enough kinetic energy to keep momentum constant will still remain. The final kinetic energy in a completely inelastic collision, the minimum kinetic energy required to conserve momentum for any type of collision that the system may undergo. Here we have the two equations for a perfectly elastic collision. Kinetic energy is conserved. This equation consists of two objects within the system. P1 naught plus P2 naught equals P1F plus P2F, and then broken down even further. For a completely inelastic collision where the two objects stick together, we have just one combined momentum because the masses combine to become one. Momentum is always conserved in all collisions unless there's an external force acting on the system.